Okay, so what we have here is an explanation of a fabrication diagram, a streamlined method to communicate fabrication instructions. Take it away.
Alright, so for rapid development, we want to integrate the design process with the actual build process and also in documentation. So what we have is initially to start to understand the three major parts of this development platform, is we have a spreadsheet that acts as an index for all components used for a project and all the sub-process components, such as when a raw material has been processed into a state, then that would also be a component, and then when that process component becomes part of an assembly, that would also be a component that is listed in the index. And the
Okay,
second,
so specifically this is regarding the cold saw, so we have that as an example here.
So going over the second and third major examples, general examples, is we have a diagram that we're going to see an example of later on, and also a components folder which contains a list of folders. Each of those folders refers to a particular component in the index. So let's see an example to see what we're dealing with. So development cold saw, and we have inside the components folder, the build files folder, you can see a list of folders. Say there's 2.1, 2-2, 2-3, and so on, all the way to 3-1. Now the first number refers to a category, and the second number refers to a part number, and we'll see what that means in here. So as you can see, say all rectangular material is categorized by a first number 1. All process components start with the number 2, assemblies number 3, and fastener numbers 4.
Can you increase the font size a little bit, actually?
Oh, yeah, I can zoom in later.
Okay,
all right.
There we go.
There we go. So rectangular material, process components, assemblies, and fasteners all have a category number, so that we can put components into categories more effectively this way. So as you can see, we scroll down here and we see components such as steel 1 inch by 12 inch by 24 inch, and that would be 1-1. There'd be 1-2, and so on. And we actually don't need to put basic materials such as these as part of our build files folder, because they're so simple, and we can put the explanation for these within the spreadsheet itself. So for low information components, you can put the part information in the spreadsheet. But for higher information components, such as say a razor, a base razor, 2-2, then we do need to get more specific about fabrication drawings and models, because we're going to be having these as part of our computer-aided design model in the end too. So if we refer to this, 2-2 we know is a base razor, and we want quantity 1 of that, we can refer to this build files folder, go to 2-2, and we can see that there's going to be a model and a drawing. In fact, if we go to the index again and check out 2-1 base plate, we'll see that there's going to be a fabrication drawing available for us. So 2-1, and then there's going to be a fab drawing, and as you can see, files like these such can pop up, easily referred to during the fabrication stage. But most importantly, we want to put out a visualization of how we can do parallel development of all these components that go
parallel
throughout,
fabrication.
Exactly, parallel fabrication throughout all the sub-processes within a replication of a particular technology, and that is where the diagram comes in. Now you can do this with the spreadsheet too, but having parents and child, it's more software oriented for the computer to process and not very good for people to visualize. Hence we have this.
Okay, so here's our master diagram.
So as you can see, there are many numbers, say starting with 1 that from before we know starts with rectangular material. So rectangular material is cut into lengths and processed into all these different parts. We have a clamp block here, a clamp jaw here, swivel block, and for a fabrication team to visualize the entire project in this way, understand that 1-1 can be quickly referred to in the index as steel 1x12 by 24, and then understand it turns into 2-1 and quantity 1, and then refer quickly to 2-1 and go directly to the fabrication drawing, allows the team to work in parallel very rapidly with much more efficiency than you would conventional instructional that goes in steps where the team has to figure out what can be done parallel or not by themselves.
So here everything across the page is done in parallel.
Can be done
going
in parallel,
down
yes.
is the successive steps.
Correct. Going down, generally you have the successive steps, for which I don't have the assembly steps, but you can see by the first level how it goes down into say 1 to 2-1, and it goes further down. For example, this support assembly, where you cut down this rectangular piece of material into all these other components. Then you, in this particular example, you weld them together into what's called the support assembly for the cold saw.
Do you have the older diagram which had more of the depth of the steps?
Ah, yes. So
because visually that looks much more clear. Here it looks like it's spread out all across and it doesn't go far down. But you can literally map like a tree, a whole fabrication process.
Yes. So you would have arrows going down to multiple sections together, sub-assemblies coming together into assemblies, and eventually you get to the point where you're rounding down and down and down into the final assembly of the cold saw.
Do you have that example from before? See if you can find it, because that looked nice.
Okay. I'll try to find it. Oh, here we go.
Build diagram old.
We'll go back to this, and if we open that up, so as you can see, there was a description of what processes had to be undertook. So say, for example, 4-10 would have referred to the rough end milling, and it had a bit more of a down step.
So this interesting graph on one page is a visual representation of the whole fabrication process, and that's pretty neat. We can compress a lot of information to one guide page. Okay, that's a preview of the fabrication diagram. More later.